we will discuss the LCM and GCD of vulgar fractions in this video. Let us recall that multiple of a fraction a over b is obtained by multiplying it by an integer. This means that all the numbers 0 times a over b, 1 times a over b, 2 times a over b, 3 times a over b, etc. and negative 1 times a over b, negative 2 times a over b, negative 3 times a over b, etc. are all the multiples of fraction a over b. We now turn our attention to divisors of fraction a over b. A fraction c over d is a divisor of fraction a over b if a over b is a multiple of c over d. In other terms, c over d is a divisor of a over b if a over b divided by c over d has an integer as answer. A fraction a over b is in its simplest, also called reduced form, if GCD of a and b, that is GCD of the numerator and denominator, equals 1. It means that integers a and b have positive integer divisor as 1 alone. For example, 2 over 3 is in the simplest form as only 1 divides 2 and 3. But 4 over 6 is not in simplest form as 2 divides both 4 and 6. If two fractions a over b and c over d are in their simplest form, that is both are in simplest form, then LCM of a over b and c over d equals LCM of a and c, that is LCM of the numerators of both fractions, over GCD of b and d, that is GCD of denominators of both fractions. If a over b and c over d are in their simplest form, then GCD of a over b and c over d equals GCD of a and c over LCM of b and d. Let us find LCM of 2 over 3 and 3 over 4. Also GCD of 3 over 4 and 2 over 3. GCD of 3 and 4 is 1 and GCD of 2 and 3 is also 1. Hence, both fractions are in their simplest form. Hence, LCM of 2 over 3 and 3 over 4 equals LCM of 2 and 3 over GCD of 3 and 4. LCM of 2 and 3 is 6 and GCD of 3 and 4 is 1. So this LCM equals 6 over 1, which equals 6. Similarly, GCD of 2 over 3 and 3 over 4 equals GCD of 2 and 3 over LCM of 3 and 4. GCD of 2 and 3 is 1 and LCM of 3 and 4 is 12. So this GCD equals 1 over 12. LCM and GCD of any two fractions A over B and C over D is the LCM and GCD of their simplest forms. Let us find LCM of 4 over 6 and 3 over 4. Let us also find GCD of 4 over 6 and 3 over 4. To solve this question, we need to check if both the fractions are in their simplest form. This we do by checking the GCD of their numerator and denominator. As GCD of 4 and 6 equals 2, they are not in the simplest form. We convert 4 over 6 to its simplest form by dividing the numerator and denominator by GCD of 4 and 6, which is 2. So 4 divided by 2 equals 2, 6 divided by 2 equals 3 are our new numerator and denominator respectively. The reduced form of 4 over 6 is thus 2 over 3. The other fraction 3 over 4 is already in its simplest form as GCD of 3 and 4 equals 1. Therefore, LCM of 4 over 6 and 3 over 4 is equal to LCM of their reduced forms, which are 2 over 3 and 3 over 4, which equals 6 over 1, that is 6. GCD of 4 over 6 and 3 over 4 equals GCD of 2 over 3 and 3 over 4, which are again the simplest forms of 4 over 6 and 3 over 4. So this GCD equals 1 over 12. The computation of LCM and GCD of 2 over 3 and 3 over 4 we have covered just a few minutes ago in this video. The formulas for LCM and GCD of fraction are correct for more than two fractions as well. In this case, every fraction entering the formula has to be in the simplest form. If fractions A over B, C over D, and E over F are in their simplest form, then LCM of A over B, C over D, and E over F equals LCM of the numerators A, C, and E over GCD of the denominators of the fractions B, D, and F. GCD of A over B, C over D, and E over F equals GCD of A, C, and E, that is GCD of the numerators of the given fractions, over LCM of B, D, and F, which are denominators of the given fractions. Why are the LCM and GCD formulas the way they are will be explained in an upcoming video. If you are curious to know it, let us know as a comment to this video. Subscribe to this channel and stay informed.